All right. Thank you, Jacob. Hopefully that shared with everyone a good perspective of the specs, good practices, how to get things done, hearing it from the horse's mouth from somebody who's done it, and some of the challenges and things that you might apply if you haven't worked on safety edge yet in your neck of the woods, your district, or your contracts. But maybe even if you have, you can always learn from each other. So quick administrative item at the end, we are going to provide a link and a QR code for surveys. We do want to get your feedback about the seminars. We've done them a good number of years, and the feedback really helps us, not only with the content, but the delivery. One of the things we'll want to know this year is, did you like the virtual as opposed to in person? What was good or bad about it? Be curious to hear that. But we will share that survey information at the end for everyone. So I hope you hold on for the whole presentation and be able to get the information. You will get an email with that link as well. So next topic we want to talk about, I said talk a little bit about balanced mixed design, but maybe not what you expected. Instead of talking about mixed quality and testing and passing performance related laboratory tests and thresholds, we're going to talk about laydown. And Travis Light from Boxley is going to talk about their experience and whether or not it impacted field operations. So with that, let's hear from Travis.
Hi, everyone. My name is Travis Light. I work with Boxley in Salem, Virginia, and I've been asked to give a presentation to you today on the Balanced Mixed Design Initiative and will it impact field operations. We had a very unique project up in Blacksburg, Virginia in 2020, up at the Virginia Tech Transportation Institute. And because we participated in this project is the reason I'm giving you this brief. To be very simple in my explanation, it was unlike any project that I've been on. However, we learned a lot. It was not production driven. It was not see how much you can put down. It was research, collaboration, obviously testing, and problem solving to get all this done in the summer. It's a lot of research that was accomplished, through our efforts, through Box's efforts, but more importantly, all the collaboration with the other entities involved. So I'll get into that, but I just want everyone to know this is basically our experience, everything that we learned from this job, and any jobs we're just trying to let you know. So any jobs in the future that pop up, bottom line up front, you should not be scared of jobs like this. I know it seems like a lot of testing, a lot of stringent spec and stuff that you're not used to. But if you want to branch out and you've got a good QC personnel and you really want to see the effects of balanced mixed design, and in our case, high wrap balanced mixed design, go for it. We learned so much. So it's still asphalt. So the guys are still putting down asphalt. And I tell you what, the time actually laying the asphalt is very minuscule compared to the time, making pills at the plant and testing the density and cutting cores after we put the asphalt down in the field. When I really started thinking about how to give this brief, I kind of just wanted to stop right there. Like, hey, yeah, it doesn't affect it. You're laying asphalt, but the more you think about it, there's more to field ops than just, putting it down. It affects your schedule. Projects like this, obviously they take priority. If they're not taking priority, then you probably shouldn't have bid the project. The high level of I don't want to say scrutiny, because I never felt scrutinized during this project. I felt like I was being guided and helped by materials, by Salem District Materials, by the Research Council, by VTTI. it was such a collaborative effort that, you know, I can truly say that I'm honored, and my peers at Boxer are honored to be a part of it. So if you have the opportunity to get involved with projects like this, I would say definitely do it. Definitely do it. Which leads me to the third point. The experience will ultimately dictate conclusions. Well, you just heard mine. So I'll get off that that soapbox, and I'll go to the next one. All right, so here's what we were asked to do. Provide and place modified asphalt mix designs in 6 test lanes, 300 by 10, at the VTTI Heavy Vehicle Simulator Accelerated Pavement Tester. 2 1.5-inch lifts to make 3 inches total. We did not have to tack in between lifts. Here's the designs. Regular typical production mix, that 30% wrap, PG64, and that was our control mix. That was day 1. And then day 2 was 30% wrap, but optimized with BMD. Day 3, 45% wrap, PG64, optimized with BMD. Day 4 was 45% wrap, was 64 plus rejuvenator to soften it up a little bit. Day 5 was 45% wrap with a softer binder and PG58. And day 6 was 60% wrap with a softer binder and rejuvenator, as you would expect, to soften up that high wrap content. If you don't be afraid, I'm not going to go crazy into depth on all 6 of these mixes and everything. That we would be here all day. I'm really focused on the field ops. Our plant personnel and our QC personnel did a wonderful job getting this ready and collaborating with the Research Council and materials, so we could actually put it down and get the equipment at VTTI on it, so they can do the actual research. And I'll let the professors brief us up when all the research is done on how each mix performed. But we will give you our perspective as we saw it in the field. So, like, I've already talked about this, and I'm going to reiterate it again. If you have a good relationship with your materials, like your VDOT materials department, and like we do, and it's not just like we're friends out of work or anything like that. It's, you know, very professionally. We were so impressed with how professional Salem Materials ran this project. And not just them, you know, VTTI, the Research Council, and, you know, the Asphalt Association sat in on a lot of the calls. It was truly a blessing and an honor to be a part of some of the people that were giving input and opinions on what we needed to do to get the project done. So it was highly research oriented and plant driven, which is completely opposite than what I'm used to, getting as many tons down in a safe manner and high quality manner as possible. Didn't care about that. I mean, you were maybe laying 80 to 90 tons a day per mix. And you're there for 2 to 3 days. Each day, that takes up a week. Ouch. If you're doing that 3 days in a row on a normal job, you know, something's going wrong. Like I've said earlier, smart people everywhere, a lot of vested interests. So as a project manager, as an operations guy, when you get involved with some of these projects, just remember, you know, it's not just you versus the customer, or it's not just you versus VDOT, which unfortunately, sometimes that happens in other projects. In this, what we did, it was collaborative from start to finish, and I was happy to be a part of it. All right, plan and execution. So 3 modes, 6 mixes, two mixes per mode. Now, I put down here 3-day minimum commitment for equipment and low volume on days of production. As far as basically, that's how it affected the field ops. I mean, I know it sounds simple, but we don't have equipment growing on trees. We got to stagger our equipment. You know, I've only, with 2 paving crews, I've got to stagger 3 sets of equipment and basically just leapfrog island hop from equipment to equipment to equipment. When you got to tie up equipment up at, you know, in Blacksburg, when you have other jobs in Roanoke or Iron Gate or Montvale and stuff like that, it's, I I mean, that's normal operations. That's normal, day to day, but still it's a challenge to know that you're tying up a set of equipment for 80 tons a day. So I thought I'd mention that. If you do plan on bidding some of these projects, I mean, you just really have to get into the research mode. It's and take a step back from what's natural, which is production. As far as time commitments and collaborative effort, I've felt like I've hit on that a lot already. Weekly conference calls with all players involved. Field ops needed to stay flexible depending on the progress of the mix designs, test track, and personnel availability. So you throw a date out there, the date changes, you flex, you adapt, and you go with it. But the thing is, you got to make this stuff a priority, because there's so many people depending on what you say is what you're going to do. So if you give them a date, everyone's working towards that date to get the test track ready, get the testing equipment ready, get the mix designs ready. You really gotta, once you commit, it's full go. And then max effort in managing variables and creating constants. I'll get into that in a second. Managing variables. I wish I could manage all the variables in my life, as well as the QC personnel managed all their stuff, at the plant and in the field, really. But there were pills required for each lift of asphalt produced in the test lane. So 2 sets of 12 per lift of asphalt, 48 total pills per asphalt type. So a lot of pressure on the QC personnel to sample between lifts. They could not send the second lift with everything in this contract until they had a certain number of pills pass after the first lift. Well, they can't tell that how many pills will pass after the first lift until the pills that they took after that first lift cool. So one of the things that we ran into, or QC ran into at the plant, was they had to figure out a way to cool these things down quicker, because we're sitting there up in the field with rain coming, like, hey, hurry up. We cut all our cores. The new guys are already starting to weigh the cores and everything. We're just sitting there, ready to go and looking at weather on the radar. So that was just the first couple of days. But after that, our QC got with materials. And like I said, we had a weekly conference call, got with VTTI, got with the Research Council. What they do, they went and got another air conditioning unit and 2 high-powered fans to cool down the pills quicker. And once they did that, man, everything changed. Something that simple. So credit to them. After the first mob, the first 2 mixes that we put down, everything really kind of balanced out as far as time needed at the plant, the load, haul time, and installation and field testing. So obviously, plant driven. Once they're ready to go, we need to make sure all resources with one round would get us the asphalt that we needed. So we made sure we had 3 trucks there at all times. Each lift of asphalt was 30 tons. So we'd have one get loaded, go. The other one would take a sample, which they would get the pills off of, and then the third truck would get loaded and come up to Blacksburg. It's about a 45-minute haul. But once they were ready, we had to get it down. So we had to stage, maintain equipment appropriately. No time to spare. We had spare equipment on site, so if a roller went down, we could easily replace it. And we had a spare paver close at another job in Christiansburg, but it was still close by. If we needed to go get it, we could. The heroes at the plant getting all their samples. So creating constants. This is something that they really harped on, and not harped, but for good reason. They needed to. We needed uniformity on all these mixes, as much uniformity as we could, as much that was going into getting these mixes to pass the balanced mix design process. The least we can do is lay them at a uniform depth, right? So 3 inches, our allowable thickness tolerance was 1/4 inch. And it seems easy, but with the changes and everything that were going on in the lab, some mixes compacted different than others. So you really had to pay attention on your roller pattern. And that was the key with the roller pattern, other than just density numbers, but seeing how that mix compacted where you're going to set your chunker at. So that was a lesson learned, that if someone gets this, another contract like this in the future, just be mindful. A lot of cores taken, a lot of cores. So I had about half the crew out there with saws and the other half with leaf blowers blowing all the dust out, so we could get all the cores cut in a timely manner. Because towards the end of the summer, the plant was really moving and humming along, and they were ready to send the second lift. And, we didn't want to be out there till 5 or 6 o'clock each day. Field performance. So the only mix we struggled to achieve density on was actually the first lift on the very first mix that we laid, which was the control mix, which wasn't a good start. But like I said, we had wonderful collaboration with materials and the Research Council. We continued, and then we ended up milling up that lane and putting it back later on in the summer. So we had a valid control to go off of. But lessons were learned from that. We got a bigger roller out there, and made sure that we were putting the lifts down at a constant as the other lanes. Where all the lanes were 10 foot, that lane ended up being 12 foot, but that really doesn't matter. We fixed it, and we got a good control towards the end of the summer. All other high wrap mix optimized with BMD had no problem achieving density, and they did so rather quickly. So that's important as far as lesson learned. When BMD does become the thing, and we are on contracts in which we're trying to get production, that is going to help, because the density was achieved quickly. That means lesser roller patterns. So that is something that will affect field ops positively in the future. As far as this certain project or any other pilot project, research driven in the future, probably doesn't affect it that much. But when you're trying to lay as much as possible on some of these production driven contracts, it's going to be a big deal. So the one thing that I think, the one mix that impressed everybody, well, two mixes, was the high wrap. They were all high wrap, but 45% wrap, PG, the normal binder with rejuvenator to soften it up a bit, and then the 45% wrap with the softer binder. They seem to impress the most. Solid density, achieved relatively quickly, just like I mentioned earlier, and the mix remained extremely workable despite the high wrap content. And everyone knows high wrap content means lower production cost. So I wish we had better pictures. You really can't see, like, as far as the pictures that we took of all the mixes. I mean, it just looks like mix, but people that have a chance to make this mix and lay it, I think you're going to be impressed. It was a beautiful looking mix. The high wrap content helping obviously stiffen it up, but the rejuvenator and then the softer binder bringing it back to a more balanced state. It was a wonderful mix to look at. Impact of high wrap BMD mixes on field ops. So like I said, that's really all we did in this project. I mean, it was all high wrap mixes optimized with BMD. So positive, easily obtainable density results, quicker roller patterns will speed up production, and the higher wrap percentage will reduce production costs compared to traditional mixes and also provide better performance. Negative is, hey, if you're producing a larger amount of high wrap mix, naturally that requires bigger wrap stockpiles. So you better have enough work to keep your milling crew busy. High wrap mixes without rejuvenator or softer binder are way less workable and way less resistant to cracking. So all in all, just to conclude, again, this was one of the most unique projects Boxley has had the pleasure in participating in. Other contractors out there, you should not be afraid. You're going to learn a lot. And if you've got room in your backlog and you've got, flexibility in your schedule, I would encourage projects like this, especially with the type of people that we dealt with. I'm sorry about that. You should not shy away. So the spirit of cooperation can go a long way. We learned that. on this project, and we'll continue to try to get back and do some of this, more of this in the future, to be honest. Macro level operations are the ones most affected. We talked about the schedule. You're really blocking out a week of time for one crew, and especially a set of equipment. Low volume, equipment redundancy, making sure you have spares there, because once the plant's ready, we need to perform. The time it took during the day, so you're going to have high labor with low tonnage. That's just the way it's going to be. But just realize it's research driven, and this is the way it has to go. And priority. You have to make projects like this a priority, or it's not going to work, because everyone else is going one direction. You need to make sure you follow suit. Managing the testing variables and creating field constants, advance the project in a timely manner. We just went over that. The QC guys did great as far as speeding up when they had enough pills to continue production. And as long as we did our part, laid the proper depth, made sure we achieved density, the project moved on smoothly. Future high wrap mix projects with higher volume and less plant sampling will be very attractive due to increased production, less roller passes, and decreased production costs. What more could you want, right? I mean, other than having to keep higher stockpiles of wrap, and how much milling work you have as far as in the future if they do go to these high wrap mixes. But the less roller passes will speed you up, and obviously it'll cost less to make the mix. Overall, I hope I was able to glean some information on some of the unique aspects of what we experienced last summer. The overall message I'd like to send to everyone here, and thanks for listening to me, is that, this was a wonderful experience, and we learned a lot from it. I encourage everyone to try to be a part of one of these projects in the future. And will it affect field ops? Yes, it'll affect your schedule. It'll affect the way you think on certain timelines and on certain days of production. But end all be all, you work as a team with VDOT and Research Council and the Asphalt Association, and I think we gave them a good product. So I'm really excited to see all the research that comes out of it, and I hope that everyone here has learned a good bit of what some of these projects look like for bidding in the future. Hope everyone has a good day, and thank you for your time.
All right, thank you, Travis. Good stuff. Please, a reminder to everyone, as we go through this afternoon and these last few presentations, don't forget, enter any questions you have in that Q&A area. We're getting them as they come in, and we'll plan to take them and provide answers as much time as we have before 3 o'clock. So don't forget, send us your questions in the Q&A area. So we're running a little bit behind on time. We actually make it a good bit of it up with the last couple presentations, but I'm just going to roll right into the next one. It's me making a presentation many of you have seen before. If you attended the Mid-Atlantic Conference and Expo virtually, May Light, it's what it was called because it was virtual back in December. I covered 2021 spec changes. Fair warning, the first 6 or 7 minutes does focus more on just hierarchy of contract requirements and the different types of specs, contract language. So we'll cover that and then get into what is a very short list of changes for 2021. So slide over there and start that video.
Hi, everyone. My name is Travis Light. I work with Boxley in Salem, Virginia, and I've been asked to give a presentation to you today on the Balanced Mix Design Initiative and will it impact field operations. We had a very unique project up in Blacksburg, Virginia in 2020, up at the Virginia Tech Transportation Institute. And because we participated in this project is the reason I'm giving you this brief. To be very simple in my explanation, it was unlike any